Statistics Chapter 3, Lesson 3 goes over the addition rule in probability. Terms we need to know. The first one is a compound event. This is when any event combining two or more simple events happens. The way we express this in terms of probability is the probability of A or B happening, which means A happens, or B happens, or both events happen. So for example, you could find the probability that it is sunny and it is windy. Or it is windy. So you would find the probability of it being sunny and the probability of it being windy, or the probability of it being both sunny and windy. Your addition rule, what this lesson is about, is the following. This is how we find the probability of a compound event. You're going to take the probability of A happening plus the probability of event B happening, and then if it's necessary, if there's an overlap, you're going to subtract from that the probability of A and B happening, so when they happen both at the same time. We have events that are called mutually exclusive. Right? This is events that can't occur at the same time. So, for example, if we think about the weather, it can't snow and be 90 degrees. Okay? So those would be mutually exclusive events, snowing and it being 90 degrees. We have complementary events, and these have to be mutually exclusive. Oops, and it went way too fast, so let's back up a little bit. Okay, our complementary events are expressed P of A or A prime, and that apostrophe after the A is the A prime. So what we would do here is we would take the probability of our event happening, add it to the probability that it doesn't happen, and this should equal 1. Okay, so your complementary events, if you add the probability of something happening plus the probability that it doesn't happen, it should equal 1, because your fractions, you should get the same number over the same number. Now let's move on to some examples. You're going to need to refer to Table 3.1 on page 137 for the following examples. First example, if one of the 2,072 subjects that are represented in Table 3.1 is randomly selected, we want to find the probability of getting someone who used a placebo or was in the control group. Okay, so we first need to figure out if these events are mutually exclusive or not. Okay, well, if we think about what we already know about how we conduct experiments, we know that if you're in the placebo group, we can't be in the control group. So these are mutually exclusive, which means I don't need to subtract the people that are in both of these groups. So if you look on your chart, you will find that there are 665 people that were placed in the placebo group, 626 people in the control group, and what I did was I added 665 and 626 together to get 1,291 people in both of those groups, and I put it over the total subjects that were in this entire survey. So we had 1,291 over 2,072. Now you'll notice I turn this into a decimal, and when we start getting into the addition rule, multiplication rule, and deeper probability, they're going to express them as decimals because they're a little bit more meaningful. I can turn this decimal, 0.623, into a percent, and it makes it a little bit more meaningful to us to say that 62% of these people surveyed were in the placebo group or the control group. Okay, so you don't have to turn them into decimals, but like I just said, it makes it a little bit more meaningful. So moving on to example 2, again we're dealing with this same chart. So again, if one of the 2,072 subjects represented in this table is randomly selected, we want to find the probability of getting someone who used Celandine or did not experience a headache. Well, if you look on your chart, you'll notice that these people, there is an overlap. So you'll notice in my problem, I found the total amount of people who used Celandine, which was 781. I found the total amount of people who did not experience a headache to be 1,950. And then I needed to subtract the people who used Celandine and did not experience a headache, which was 732. So once I added 781, 1950, and then subtracted 732 from it, my grand total, without an overlap, was 1,999 people. And again, since I'm using the same survey, I need to put it over 2,072. And I'm going to turn that into a percent or into a decimal, which we can interpret as a percent, to be 0.964 that did not experience a headache and used Celandine. So we can say most of these people in this survey didn't experience a headache or they used Celandine. Now that we've done a couple examples together, I want you to use these next two examples to try on your own to find the probability that each of them asks you to find. So go ahead and attempt those, and if you have questions, I'll answer them next time you're in class.